Hello, good morning, friends. Today we are going to discuss about the robot kinematics. In robot kinematics, basically there are two classifications, broadly classified into two groups. That is forward kinematics and the direct and the reverse kinematics. All right. So in this case, as per our syllabus point of view, we have uh, two criteria, that is 2D and 3D. So first of all, let us we consider and understand what exactly the forward kinematics and the reverse kinematics. All right. So let us consider. Uh, let's consider first robot arm, which is made up of two links with end effectors. So this is the coordinate. This is x coordinate. This is y coordinates. All right. So first consider there are two links, which is one is adjoining at the origin, and second is with the, this is the first link, which is made up of length L1 and makes an angle with the x-axis, that is theta 1, which is anti-clockwise direction. Here we assume uh, theta, that is counterclockwise direction, take as positive. All right. And if we are talking about the theta in clockwise direction, take as negative. All right. So this is the first link, which is length having L1 with the theta 1 angle or angular position with the x-axis is theta 1, and this is the second link. Let's suppose this is if we extend the link 1 makes one axis, that is this is the axis of link 1. So this is the angle with the with the link first. All right. So link 1, with respect to link 1, the position of link 2, angular position of link 2 is, that is theta 2. All right. So let's suppose this is the link having length 2. Now that, consider this is the end effector, and the coordinate of end effector is, let's suppose, small x and small y. All right. Let's suppose this is point O, this is point A, this is point P. All right. If we are talking about the absolute position of the link, this link with respect of the x-axis, that is phi, and we know that phi is nothing but is the combination of angular position of link 1 and link 2, that is theta 1 plus theta 2. All right. So uh, on the basis of these kinematic mechanics mechanism, there are two configurations. That is, first is joint space, and second is world space. Second is world space. All right. Joint space means we are talking about the angular position of intermediate links. Here we have discussed only two links. So the angular position of link 1 is theta 1, and angular position of link 2 with respect of this link, first link, that is theta 2. And also this is also given, that is link 1 and link 2 length. This is always known. This is always known to us. Okay. If in first case, if angular position of link 1 and link 2 is given, and we want to achieve the world space means the absolute coordinate of end effector, that is x and y, that is point P. That means if we want to achieve what is the position and position of end effector with respect of absolute position, then this mechanism is called as and this mechanism is known as forward mechanism. Alright, forward kinematics. And kinematics, we all know that nothing but is the study of motion or angular position. Here we just deal with the angular position of the intermediate links. So when we have theta 1 and theta 2, that means angular position of the link 1 and link 2, then we will achieve the end points or end position of end factor, that is the coordinate of p, that is x and y. Then this mechanism is known as forward kinematics. All right, but in the reverse manner, that means if we know the end effector position, that means we know x and y, and we want to find out the angular position of intermediate links, then this mechanism is called reverse kinematics. This is known as reverse kinematics. All right, reverse kinematics. Forward kinematics, that means it is also known as direct kinematics, and this is also known as inverse inverse kinematics. All right, inverse kinematics. So based upon their initial position to the final position, we classified robot kinematics into two groups: forward kinematics or direct kinematics, and other is reverse kinematics or inverse kinematics. Okay, so the first we will discuss about the forward kinematics. All right, so the first topic is forward kinematics, or it is also known as direct kinematics. All right, so forward kinematics or direct kinematics, that means we know the angular position of intermediate link, that is theta 1, theta 2, obviously link length L1, L2, and we will evaluate, and we will find with the help of these angular position, we will find the absolute coordinate of end effector, that is x and y. Also we can find out the value of phi, and phi is nothing but is not theta 1 plus theta 2. So if we know the intermediate position of link 1 and link 2, that is theta 1 and theta 2, automatically we get the value of phi. So need not do any kind of further calculations required. Okay, so the first case 1, we will discuss about for 2D case. All right, 2D case. So let us consider again robot intermediate coordinates. Let's suppose this is y, this is x. This is the first link of link length 1. This is link 2. Angular position, that is anti-clockwise direction theta 1 with respect to x-axis, and with respect of link 1, angular position of link 2 is theta 2 with respect of absolute position, that means from the x-axis it's known as phi, and phi is nothing but theta 1 plus theta 2. All right, and this is nothing but original 0, coordinate are 0 0. This is point A and this is point P. Here the end coordinates are x and y. All right, so here we are going to discuss with the help of theta 1 and theta 2, we will find out the absolute coordinate of x and y. That means here this is nothing but is the end effectors. All right, so position of end effector with the help of intermediate angular position. So let us this is considered as link 1, and using of the sine and cosine formula, we will find out the value of this. So if this is L1, this length is L1, this length is L1, and this makes theta 1. So the length of this, suppose this is point B. So length of AB is nothing but is called L1 sine theta 1. Alright, and similarly, this length is known as L1 cos theta 1. Okay, so what we have do, just we classified link L1 with respective of absolute coordinate x and y, that is x and y. So perpendicular to the y x, the position of L1 link is nothing but L1 sine theta 1, and perpendicular to the y axis, the position of first link L1 is nothing but L1 cos theta 1. Similarly, we can find out the value of L2. Alright, so if we consider the position of L2 not with the theta 2 in terms of absolute angle, that is phi. So this is the position of link 2 in perpendicular to the x direction, this. Alright, so let's suppose this is the complete angle. This is the complete angle. This will be nothing but L2 sine phi, and sine phi is again theta 1 plus theta 2, and the position of parallel to the x-axis or perpendicular to the y-axis is nothing but L2 cos phi, that is theta 1 and theta 2. Alright, so if we are talking about the end point, this is nothing but position of x, this is the position of x. Alright, and this is the position of y, this is the position of y. So coordinate x is nothing but L1 cos theta 1 plus L2 cos theta 1 plus theta 2. Alright, so we can calculate the position of x with the help of this equation. Let's suppose this is equation number 1. Similarly, coordinate of y is L1, this is the position of y. So L1 sine theta 1 plus this position, that is L2 sine theta 1 plus theta 2. This is equation number 2. So we know the position, the link length L1, link length L2, and we know the intermediate position theta 1 and theta 2. Then we can easily find out the absolute coordinate of this robotic arm, that is x and y, based upon these equations. Alright, so this method is nothing but is called the forward kinematic mechanism. Forward kinematic means we know the we know the position of intermediate links and length of the links, and we'll find out the value of and coordinates. All right. Okay. Next is okay, and the second part, that means second case number 2, which is nothing but inverse kinematics, or it is also known as reverse kinematics. That means in this case, we know we know the absolute coordinate, that means x and y, Similarly, we know the angle phi. Then we will evaluate. We will find out the obviously L1 and L2 is always known. This is always known for us, and we will find out the intermediate position of the links, that is theta 1 and theta 2. This mechanism is nothing but is called the inverse kinematic mechanism or reverse kinematic mechanism. Let us consider again this graph. Coordinate y and coordinate x. Alright, so this is the position of link 1, length L1, which is also known, and this is the second link, length 2, and this is the end point, let's suppose x y, which is already known to us, and we will find out the value of theta 1, and with respective of first link the angular position of link 2 is theta 2, and with respective of absolute coordinate, that is x, its position is phi, which is nothing but theta 1 plus theta 2. So here we are going to calculate the theta 1 and theta 2, value of theta 1 and theta 2. Okay, so we know this is the length L1, this is the length L2, and if we extend this point P in this direction, so this the point, we extend this point, let's suppose this is the original point A, this point B, and draw a perpendicular to this extension, let's suppose this is point B. Okay, and we join this link also, origin with the last link, sorry, uh, and we join the point O with P. Alright, so this becomes OBP. It's a right angle triangle. Alright, so this is the position of x-axis, that means length of x, sorry, this is the y, and this is the x, position of x. Alright, so from this triangle we can easily find out this is the perpendicular between x and y coordinates. So easily we can find out the length of OP, that is nothing but with the help of Pythagoras theorem, OP square is equals to x square plus y square. Alright, so let us suppose this is equation number 1, and length of sorry, there will be a slight modification. We find out the value of not OP. We will find so correct. It's correct. So OP from triangle, from triangle OBP. Okay, we apply Pythagoras theorem again, and we will find out the value of OP square is nothing but OB square plus BP square. Right, so this is the OP length square, this is the OB length, and this is nothing but is called the OBP length, and BP length, from this we can calculate, this is the nothing but L2, L2, and this make an angle theta 2, so become sine of theta 2. Right, now we are talking about O and B, length of OB. So this is, let's suppose this is question number next, question number 2. So the length of length of PB, length of PB is nothing but L2 sine theta 2. Alright, Now the point OB, length of OB. OB is nothing but length of L1 from here to here, that is OA, which is nothing but length L1, and this is nothing but is known as L2 cos of theta 2. Alright. So in this way we can find out the value of PV and OB. PV and OB. By putting the value of PV and OB in equation number 2, from equation number 2 we will get, we will get the length of OB, OP, OP square. Again we write the equation, this equation, OP square equals to OB square plus this BP square. Alright. So from equation number 2, put the value of OB. So the value of OB is nothing but, the value of OB is L1 plus L2 cos theta 2, L1 plus L2 cos theta 2 का whole square plus BP from this equation, then L2 sin theta 2, L2 sin theta 2 का square. Now okay, now extend this equation, that is L1 square plus L2 square cos square theta 2 plus 2 L1 L2 cos theta 2 plus L2 sin theta 2 square. Alright. So let's suppose this is L1 square plus this is common from L2 and L2, so L2 square from this point and this point. We will find out the common is sin square theta plus cos square theta. Alright. Plus rest term, that is twice of L1 L2 cos theta 2. Alright. So in this way L1 square same, L2, this is sin square theta plus cos square theta, again this is theta 2 and theta 2, theta 2 and theta 2, this becomes 1, so this will be left as L2 square and twice of L1 L2 cos of theta 2. So so in this way this equation comes that OP square is L1 square plus OP square is nothing but L1 square plus L2 square plus 2 L1 L2 square, which is nothing but is called x square plus y square. Alright. So from this terms we will find out the value of cos theta 2. So transfer this terms into other side, that is twice of L1 L2 cos theta 2 is equals to x square plus y square minus of L1 square plus L2 square. Alright. So this term transfer from this side, and cos theta 2 is nothing but x square plus y square minus L1 square plus L2 square divided by twice of L1 L2. Okay. And theta 2, that means intermediate position of link 2 with respective of link 1, becomes cos of inverse x square plus y square minus L1 square plus L2 square divided by twice of L1 L2. So in this method you can find out the value of intermediate position of link 2 with respective of link 1. So in this way theta 2 is find out, and we know that phi is nothing but summation of both position of intermediate link, that is theta 1 theta 2, and you have already know the value of theta 2, so you can easily find out the value of theta 1 is nothing but theta 2, sorry, phi minus theta 2, phi minus theta 2, phi minus theta 2. All right, clear? So next topic is forward kinematics. Forward, but before come to the forward kinematics or direct kinematics, forward kinematics or direct kinematics for case, sorry, we have already discussed as 3D. 3D. All right. So 3D means we are talking about 3 degree of freedom, and for robot we have already discussed that 1 degree of freedom means one kinematic pair. All right, so one kinematic pair means 1 degree of freedom. So if we are talking about the 3 degree of freedom, that means obviously the mechanism having three kinematic pairs or joints. All right, so this will be discussed in the next lecture. If you have any doubt and query, please ask. Thank you very much.